So ladies and gentlemen, here's lesson 2.3 for our geometry concepts. We're going to take a look at complementary and supplementary angles. So these are special angle relationships that we have, and as we go through this chapter, we're going to start building our ideas and understandings of angle relations. So our goal for this lesson is to find the measures of complementary and supplementary angles. So the first thing we want to do is build your vocabulary. So like I said, you may need to pause. But complementary angles are two angles whose measures have a sum of 90 degrees. So we've got two angles, and they're going to add up. So sum means to add to give you 90 degrees. A complement is the angle measure an acute angle would need to have a sum of 90 degrees. So we would look at if we have a 30-degree angle, its complement is 60 degrees because 30 plus 60, let's see if I get more room here, because 30 degrees plus 60 degrees equals 90 degrees. So we would say 60 is the complement of 30 degrees. We now have supplementary angles, and they're just two angles whose measures have a sum of 180. So we've got these two relations. Sum is 180. Supplements add up to 180. Complements add up to 90. And as I'm assuming you're looking at that, you're going to have to figure out a way of keeping those straight. And as we move through the lesson, we're going to work on memory devices, mnemonic ideas, on how to keep complements and supplements straight. But supplementary angles are two angles that have a sum of 180. So then the supplement is the angle measure an angle would need to have a sum of 180. So once again, if I had a, let's say I had a 40-degree angle, its complement would be 140 degrees because 40 degrees plus 140 degrees equals 180 degrees. Okay, so we're looking for two things that when added together equal 180. Adjacent angles are two angles that share a common vertex and side, but no common interior points. What that common interior points means is that there's no overlap. So vertical angles, adjacent angles, I'm getting ahead of myself in lessons, are a lot of what we've been looking at already this chapter when we have bisected angles, only they don't have to be congruent. So angle 1 and angle 2 are what we call adjacent angles because they have a common vertex and they have a common side. All right, so they have to be right next to each other. They're adjacent to each other. But notice angle 2 is a distinct angle all on its own. Angle 1 is a distinct angle all on its own. There's no overlap between those two angles. And last but not least is theorem. And a theorem is just a true statement in mathematics that can be proven by other true statements. We started out in chapter 1 with a vocabulary word of postulates. And postulates were true statements in mathematics that were simply accepted as being true. We didn't have a way of proving them. Well, now what we have are theorems, and we're going to be using postulates, using properties, using vocabulary to start proving these statements so that these can be known as true statements. And that's one of the reasons I love mathematics, because everything can be proven true. So we introduce you to your first two theorems in our geometry class this lesson. All right, so our follow-up. We want to think of ways to help you remember the meaning of each term. So what I want you guys to do is figure out, how do I remember complementary angles? So two angles that add to equal 90 degrees. And then supplements are two angles that add to equal 180 degrees. So we will go over this in class. I'm going to call it a check, but it's actually going to be a go over in class, see what ideas you guys came up with. And then fortunately with my 15 years of teaching, I've got some ideas that I can share with you on how we can remember these. All right, so example 1, we need to identify angles. So we're going to be identifying angles as complementary, supplementary, or neither. So we take a look at those. So when we look at A, we have two angles. We have a 22-degree angle and we have a 158-degree angle. We want to add those together because that's the only way to know if they're complements or supplements. You have to be adding them together. So 22 plus 158 is 180. You can use your calculator. So because it equals 180 degrees, the angles are what we call supplements. And notice they make the straight line that we expect a 180-degree angle to make. If we look at example B, we have a 15-degree angle. We have an 85-degree angle. And when we add those together, we get 100 degrees. Now, when you look back to what our definitions were, and you can just look on the page to your left, the two angle measurements we were looking for were 90 and 180. Since 100 is neither one of those two measures, then these two angles do not have either of these relationships. So they are neither supplements nor complements. And so when we look at angle C, we have a 55-degree angle. We have a 35-degree angle. We want to add those together, and as you could probably guess, that is going to be 90 degrees. So because it is 90 degrees, the angles are complements to each other. All right, so that's going to be how we determine if they're complements or supplements. We can't just look at the pictures and go, those look close. We mathematically have to prove by using the definition. A sum, so sum means we're adding two angles together to equal 180. We are going to have a sum, so two angles added together to equal 90. All right, now we have to look at this definition of adjacent angles. That was the second set of definitions that we gave you after we defined supplementary and complementary angles. So we want to look at whether the two angles are adjacent or non-adjacent. So it's either a yes or a no for that. So when we take a look at this, we have angle 1 and angle 2. It says because the angles do not share a common vertex or side. Here's the vertex of angle 2. I'm coloring that in red. Here's the vertex of angle 1. I'm coloring it in blue. There is no common. Those are two distinct vertices. And so as soon as we do not have a common vertex, we would say that they are non-adjacent. So to me, one of the things that helps me out is that if I'm looking at adjacent angles, they at least need to be touching. Okay, just because they are touching each other doesn't mean they're going to be adjacent, but I can distinctly tell from angles 1 and angle 2 because they weren't even touching that they're non-adjacent. All right, if we take a look at example B, it says because the angles share a common vertex. So here's my common vertex. And they share this common side. So this is kind of what the definition looked like when I drew it in there. They have a common vertex and they share a side. Angle 3 and angle 4 are what we will call adjacent. Adjacent is side by side. I've always used the definition for adjacent as you and your neighbors are adjacent to each other. Your properties are right next to each other. No one can be in between you. But your yards don't overlap. You don't share your part of your yard with your neighbor. There's a distinct line between that. And so that boundary line that separates the two properties, the boundary line that separates the two angles is what makes them adjacent. And so if we look at C, it says although 5 and 6 share a common vertex. So we do have a common vertex. We have angle 5 coming to that, and we have angle 6 coming to that. Okay, so even though they have the common vertex, they do not share a common side. If I look back up at my diagram that we had here, we have two distinct rays that are red. No green on any of them. I have two distinct rays that are green. No red on either of my green rays. So that means they do not share a common side. And so therefore angle 5 and angle 6 are non-adjacent. All right, so even though we are together, because there's a space, so there cannot be a gap. The gap is what makes them non-adjacent. So 3 and 4 are side by side, common vertex, no gap. That makes our adjacent angles. All right, so now we're going to take a look at actually using this idea of finding complements and supplements. It says angle 1 is the complement of angle C. So they're telling us this. They give us this. We're not trying to figure it out. This is given to us. I know this. And I know that the measure of angle A equals 47. Find the measure of angle C. So if we go down and take a look at the solution for this, it says angle A and angle C are complements. So the measure of angle A plus the measure of angle C is 90 degrees. So that means I can start using some substitution. 47 degrees plus the measure of angle C has to equal 90 degrees. We solve this as we would any other equation. We're going to subtract 47 from each side. And so when we subtract 47 from each side, we end up with measure of angle C equaling 43 degrees. If we take a look at B, it says angle P is a supplement of angle R. I don't need to decide that. They tell me that. And so now I know a property. I know that because angle P and angle R are supplements, the measure of angle P and the measure of angle R equal 180 degrees. Well, they go on to tell me that the measure of angle R is 36 degrees. So I know the measure of angle P plus 36 degrees has to equal 180 degrees. When we look at this, we're going back to the same algebra. We're just subtracting 36 degrees from each side. So when we subtract and solve for the measure of angle P, we get 144 degrees. All right, here's our checkpoint. It says state whether the angles are complements, supplements, or neither. So we're going to treat this one as a check-in class. And I'm going to call people up to the board to do this. But what I want you to keep in mind is that complements add to equal 90 degrees. Supplements add to equal 180 degrees. And complements add to equal something else, if it's going to be neither. So what you need to do is look at the two angles in example 1, add those together and see what they equal. Take the two angles in number 2, add those together and see what they equal. Take the two angles in problem 3, add those together and see what they equal, and then pick your description, pick your category for each of those. But we'll check that one in class. All right, checkpoint number 4. It says B is the complement of D, and the measure of angle D equals 79 degrees. It says find the measure of angle B. Well, let's go back to what we know. We know that the measure, if they're complements, the measure of angle B plus the measure of angle D equals 90 degrees. So what I need you to do, and this is going to be another one that we check in class, you're going to need to do your substitution and solve for the measure of angle B. For 4, they tell us that they are supplements. Angle G is a supplement of angle H, which means the measure of angle G plus the measure of angle H equals 180 degrees. So what you're going to need to do is use your substitution, plug in what you are given in this problem, use your algebra, and find the measure of angle H. So you're solving for measure of angle H, measure of angle B. I'll bring someone to the board tomorrow to check those in class. All right, now we get our first two theorems. All right, we have what's called the congruent complements theorem. So it says if two angles are complementary to the same angle, then they are congruent. So what that means in terms of symbols, we've got the diagram here. So we know that angle 1 plus angle 2 add up to 90. Excuse me. And we know that the measure of angle 2 and the measure of angle 3 add up to equal 90. So since 2 is this common thing in there, what we know is that angle 1 is congruent to angle 3. So the two things that are being added to angle 2, those are the two things that are going to be congruent. This set equaled 90. This set equaled 90. So 1 and 3 have to be congruent. Theorem 2.2 is congruent supplements. So it says if two angles are supplementary to the same angle, then they are also congruent. So if angle 4 and angle 5 add up to equal 180, and the measure of angle 5 and angle 6 add up to be 180, if we take out this constant of angle 5, that means then angle 4 is congruent to angle 6. So the two angles that you're adding on to angle 5, those become your congruent angles. So we're going through these theorems. It's going to make a little bit more sense when we start looking at applying those. So what we know here is that angle 7 and angle 8 are supplements. We can see that they make a straight line, so that angle 7 and angle 8 are supplements. We know that angle 8 and angle 9 are supplementary because they make a straight line. And so what we need to do is name a pair of congruent angles. Explain your reasoning. So if we notice we've got angle 8, that's in common between these two. So angle 7 and angle 9 are both supplements to angle 8. So from the congruent supplements theorem, it's true that angle 7 is congruent to angle 9. So let's think about that. This angle 8, I'm just going to make up a measure for it. It appears to be obtuse, so I'm going to call it 130 degrees. So if the measure of angle 7 plus the measure of angle 8 equals 180 degrees, if we do some quick substitution, we have the measure of angle 7 plus 130 degrees equals 180. Solve this little equation. We're going to subtract 130, so I have the measure of angle 7 equals 50 degrees. All right, well, we also know that 8 and 9 are supplements from our diagram. They made this straight line here. So I know the measure of angle 8 plus the measure of angle 9 equals 180 degrees. That's our definition of being supplements. They tell me that at the beginning of the problem. So now I'm going to go through and do some substitution. Angle 8 hasn't changed. This diagram is still the same, so angle 8 has to be 130 degrees. Plus the measure of angle 9 is equal to 180. I'm going to solve by subtracting 130. So I get the measure of angle 9 is equal to 50 degrees. If we take a look at what our answers were, we have angle 7 equaling 50 degrees, angle 9 equaling 50 degrees. So we're going to get the same answer because angle 8 is a constant. It's not changing. All right, so we're going to take the checkpoint. We're going to go through and take a look at it. We're going to start it here, and then we'll kind of we'll finish it in class. So if we look at the diagram, it says the measure of angle 10 and the measure of angle 11 is 90 degrees. We kind of see that corner angle there. And they tell me the measure of, so this is what they tell me in green. I just highlighted that in green. They then tell me that the measure of angle 11 and angle 12 also equals 90 degrees. We need to name two pairs of congruent angles. Well, we have angle 11 in there. All right, in both of those, that's what they have in common. So what's left to be congruent angles is the measure of angle, or I shouldn't say the measure, we say angle 10 is congruent to angle 12. Well, what you need to do now is explain your reasoning. And so when I give you guys a chance, you'll share in class. You'll do a pair share. And then we'll report back on the board. All right, ladies and gentlemen, this is the end for lesson 2, 3 that we'll be working on in class on Wednesday.